Welcome to the basics of Algebra 1. In this video, we're going to talk about variables, coordinate plane, correlation, all those kinds of things that you've learned in the past, but we're just going to kind of review some vocabulary so we can all start on the same page. So first thing is, what's a variable? In Algebra 1, we will be using lots of variables, which are symbols, usually a letter, that represents one or more numbers. So variables are going to be used to represent different things that we need throughout our work. Algebraic expressions are mathematical phrases that can include those variables, numbers, and operations. And then we've got equations. The difference between an equation and an expression is that equal sign. Oftentimes, we're just looking for an expression. So we don't need that equal sign. You can simplify an expression. Equations you solve. Those are going to be two key words that you'll hear me repeat over and over throughout this unit. So with Algebra 1, we're going to be looking at solving those equations or writing and simplifying algebraic expressions. So as we start to write these equations or expressions, we want to think about our key words. And we have our four basic functions of addition, subtraction, multiplication, and division. And oftentimes as we're reading, we need to translate our words into one of those expressions. And so we have to understand all of the ways we can talk about adding. When you hear things like sum, plus, add to, more than, increase by, or total, that is usually a great indication that we need to add. If you hear words like difference or minus, less than, or decreased, then we're going to subtract. Multiply, product times, of, multiplied by, twice, double, triple, those are all good cues that we're going to multiply. And then division, quotient, divided by, into, ratio. So we'll talk about those. Those are just some, they're not all of them, but we've got a lot of different vocabulary words we can use to explain our different operations. So if we think about some of these expressions here, the sum of n and 10, you want to add. So you're going to have n plus 10. Whereas if we have the quotient of 9 and n, we're going to divide. And I like to, that's a 9 there, use fractions to represent division. It's going to be really key in our organization as we move forward in algebra. Let's erase those so we can have some room for the next ones. And so we now have, we're looking at 3 multiplied by m. This is going to be really important, and I want all of you to get into this habit. So in order to show 3 times m, we write 3m. Notice the 3 is in front. It's called the coefficient. 3, it has to be before the m. In algebra, it's going to keep you much more sane if that 3 is in front, because usually numbers after variables are our exponents. And for those of you that have questionable handwriting, trust me, I'm one of them, you want to help with your organization by always putting that coefficient in front, so you don't have to question whether it's an exponent or not. And notice we don't write any symbols between them. That multiplication symbol is understood to be there. So if you've learned the dot or the times sign with the X or the little star symbol, all of that, as we get into algebra, you're not going to need that symbol. Again, we take the lazy way out if we can. If we can save ourselves a step by not having to write that time symbol, we don't need to do that. It's already understood to be there. So, and then finally 5 less than y. So in this case, we're going to have y, and it is going to lose 5. Remember, with addition and multiplication, order doesn't matter as much, but think about the quotient and the subtraction problem there. Order is going to matter in those types of problems. Think about why that is. So if we're asked to write an equation, obviously we're looking for an equal sign with it. So we're going to pair our expressions together and join them with an equal sign. So if you think about, if you were trying to find the income, okay, we could maybe let the income be I, And how do we get that income? Well, that income is going to be created by taking 450 and multiplying it by, I'm going to use an X for the number of tickets I sell, because T's aren't good in math. They tend to look like other numbers. So income I equals 450 times X. That's an equation. Notice how I have that equal sign in there. So now we have a little bit more complex one here, in that we're not given exactly what our slope or rate of change is. So we're going to have to do a little digging here. And this should be a review from last year as well. Notice how we have our gallons. Gallons used are here. That's going to be our independent variable. And then miles traveled is our dependent. So the miles we travel is going to depend on how many gallons we've used. So gallons would appear on our x-axis, whereas miles would be our y-axis. So think about all of these things that you've talked about over the years. These are all things that are kind of automatic, but you want to make sure you're always being conscious of those. In this case, we then can look for our slope, our rate of change, and we notice that for every gallon, how many miles do we add? It's 20. So we could write an equation that represent, and I'm going to use X for gallons and Y for miles here, and that would just be our Y equals 20X. Hopefully you got that after you looked at that table a little bit more. Now we've got some vocabulary. This definition might be a little different, and you might not be as familiar with it, and that is a definition of a function. Lots of things that you've been doing throughout your math class, all of those activities and problems that you've done in the past, those usually created functions. And a function is just a relationship that assigns exactly one output value for each input value. And you're like, what? Say what? Well, if we start to dissect this definition a little bit, so it's a relationship. So it could be a trend, it could be a correlation. We might not seek trends and correlations, but it's a relationship that assigns one output value. An output, think about that. Is that your X or your Y? That's going to be your dependent, so that's your Y. So one Y value for every input, X value. Okay, so that is what a function is, and we'll probably have a bigger discussion in class on this. So don't be afraid to ask if you have more questions. That's our definition. The easiest way to determine if you've got a set of data points or relationships and you think it's a function is to use a test we call the vertical line test. And that's when you graph your points on your XY coordinate plane. Okay, remember X is our horizontal axis, and then Y is our vertical axis that goes up and down, okay? And so our vertical line test just says that if we draw a line, a vertical line, straight up and down, anywhere on our graph of data, and we only hit one point, then that relationship is a function. If it hits more than one point, then it's not a function. It's failed that vertical line test. Okay, usually if we have a function, we can write a function rule or an equation that describes that function. If it's not a function, we really don't have many options as to write a rule for it, and therefore we don't have a function rule. Here's an example of a function. And notice how if we have our inputs, these are our inputs, 1, 2, 3, 4, and our outputs are going to be the cost. Notice the trend. Notice that for every one apple we buy, our total is increased by 35 cents. So our function rule here, we could write that as y equals 0.35x. And there's our function rule. And again, this is something you've probably talked about in the past. Some other vocabulary, domain and range. These are just fancy things, names for our X and our Y, our independent, our dependent, our inputs, our outputs. And you'll hear all of those words kind of interchanged throughout the unit and throughout the year. There's two really, really fancy words. And as you're kind of glancing through your book, see if you can find those. It's a little mystery for you. The domain and the range. There's one set of names that we sometimes call it I don't use it very often, but it's in your chapter 1 of your textbook. See if you can hunt those down. That'd be a great little mystery that you guys can solve. Let me know. Maybe put it in your post video check once you find those. And then finally, our trend line. Our trend line shows that correlation more clearly. You're going to try to draw a line that kind of divides your data, shows the trend, and your points are going to have the same amount of points above and below that trend line. And then we've got correlation. And with correlation in particular, you want to think about your correlation. This is also kind of like your trend. So as your data goes up or down, what is the trend? Is it a positive correlation, which would kind of refer to a positive trend, or a negative correlation, which would refer to a negative trend or negative slope? So I like to think about correlation as if I tried to draw a line of best fit. Okay, let's see if I can do this here. If I tried to draw a line of best fit, what would that line look like? In this case, that line is going to go up from left to right. Notice how that as our x's increase, our y's increase, that would give us a positive correlation. And then a negative correlation would be down from left to right. Now notice here with no correlation, it's just kind of all over the place and we don't really have any trends. Again, feel free to ask questions. Don't be shy. Put them in your post video check if you do, or ask in class. And I'll chat with you later. Thanks for listening.